So that's delta H here is what we call bond enthalpy. So this is talking about, instead of the change of energy accompanied with a bond breaking, we're talking about a change in heat accompanied with a bond breaking. So whether when that bond breaks it requires heat, or whether it gives off heat when you break that bond, or talking about a reaction. That's what we're talking about when we're talking about enthalpy. It turns out that enthalpy is in fact very related to energy, and we can relate it with this equation here, that bond enthalpy is equal to bond energy plus the change in pressure times volume. So we could in fact go back and forth between bond energies and bond enthalpies, but the reality is if we're talking about gases, which we are in many cases, then what we find is the difference between bond enthalpy and bond energy is only 1 to 2%. So it's not very significant. And in fact, if we're talking about solids or liquids, now we can say that the difference between bond energy and bond enthalpy is going to be negligible. So for the rest of this class today, we're going to stop talking about bond energy, which I did just for a moment to orient you back to a discussion that was familiar. We're going to switch our discussion to bond enthalpies. One reason that we like to talk about enthalpies is, unlike energy, which can be a little bit more tricky, bond enthalpies are easy to measure. It's easy to measure how much heat a reaction gives off or how much heat a reaction takes in. So we can also talk about something which is called the standard bond enthalpy. So anytime you see this symbol here, which looks like a knot, so it looks like a delta H knot, that refers to the standard bond enthalpy. Anytime we're talking about a standard, whether it's enthalpy or, as we'll see in the next lecture, standard entropy or standard free energy, we're just saying that the molecules that we're talking about are in their standard states, which means they're in their pure form. If they're a gas, it means they're at 1 bar. Usually this is referring to room temperature, so 298 Kelvin. It's often that when you look up tables of different bond enthalpies, you'll see them in their standard state and it will be at room temperature. So if we talk about standard bond enthalpy, let's talk about what this is for these CH bonds, which we just saw in methane. So if we're going from CH4 to breaking one of these CH bonds, what we see is that the bond enthalpy is 438 kilojoules per mole. The fact that it's positive tells us that we need to put in that much heat into the system in order to break that bond. So we now know the enthalpy of a CH bond, but of course methane is not the only kind of CH bond that you can envision. We could talk about the CH bond, for example, in ethane or trifluoromethane or trichloro or tribromomethane. And what you'll find is that the amount of enthalpy that reaction is associated with depends on the exact type of CH bond that you have. So for example, we can see that we have slightly different, not vastly different, but slightly different changes in enthalpy depending on which kind of CH bond that we're breaking. And what I want to point out also is that all of these delta H's, all of these standard bond enthalpies are positive. Anytime we have a positive delta H, we call this an endothermic reaction.